In process manufacturing, the difference between your best production run and your average run can represent millions of dollars in untapped value. But traditional centerlining approaches can be manual, time-consuming, or can struggle to keep up with the complexity of modern operations. What if you could automatically discover the exact conditions that create your perfect run and make that performance repeatable every single time? That's exactly what we can deliver with the AVEVA Advanced Analytics Perfect Centerline model, transforming process variability into predictable excellence. Here we see the perfect centerline report for a machine at our plant. This comprehensive view shows us everything that we need to understand process performance at a glance. But how did we establish these targets? Let's go behind the scenes. The perfect centerline model starts with data, and Connect Data Services provides that foundational source of data collection and management. Here in the Connect portal, we're able to, with one click, activate Connect Data Services. We next configure a data transfer from our Pi system, and we use a no-code point-and-click interface to select exactly the PI-AF element, or Pi points, that we want to stream and sync to the cloud for analysis. With the transfer running, we can see our plant asset now synced into Connect Data Services. Here we can see that it's been successfully transferred, and on the right we see real-time properties. But before we build our model, let's refamiliarize ourselves with what's happening on the line. Here in this Connect Visualization Services display, the overall variability that we see is exactly what the perfect centerline model will help us eliminate. And we can see that the process is running, but is it running optimally? And that's what we're about to discover. Now we're in AVEVA Advanced Analytics, looking at the digital twin for Plant 1 M1. And the workflow below shows the twin preparation that we've already completed. And finally, we click to create a machine learning model for this twin. And this is where the magic happens. Here we see the many predefined model templates: perfect batch, perfect energy, perfect quality. But here, the perfect centerline model to optimize the values of a set of objectives toward a perfect centerline. In the model factory, we configure our objectives, the KPIs that define a perfect run, and we can configure up to 5, whatever matters most to our business. Next, we add our property inputs, the variables that influence our objectives. And once we've added our inputs, we move through segmentation, defining product contexts, production rate parameters, filtering rules, and transport lags. And now, with the model having been trained and deployed, each production run will be analyzed. And within each run, every process variable that we selected now has computed new centerline low, target, and high columns. These are the learned optimal ranges derived from our best historical runs, with the model having learned these ranges separately for each of the products made on this line, thanks to the model segmentation that we configured earlier. Additionally, each input has a criticality rating, high, medium, or low, which users can tailor and adjust, along with the actual values of each of the centerline limits above. But this isn't the only output from this model. In addition, the artifacts panel, amongst many other things, furthermore shows us the top model drivers, an analysis of which features have the biggest impact on our predictive model objectives. And the perfect centerline model doesn't just set targets, it also continuously monitors for deviations. The historical anomaly breakdown shows anomaly scores over time. Drilling into March 26th, we see an anomaly in the variability of our agitator watts. And the chart shows a dramatic spike, the agitator variability spiking up far outside the normal distribution and well beyond our ideal range. And the anomaly history artifact also provides a detailed trail of recent unusual behavior. Each anomaly is categorized and timestamped 24/7, 365, giving engineers the forensic data they need to understand what went wrong, when, and why. And finally, we're back to where we started, the perfect centerline report. But now you understand the power behind this streamlined interface. Machine learning models have analyzed our real-time cloud sync data, identified our best runs, derived optimal parameters for each variable, and deployed continuous monitoring and alerts to keep us on track. Operators see real-time guidance. Engineers see data-driven targets. And management sees reduced variability, improved quality, higher throughput, and lower costs. This is the perfect centerline model from AVEVA Advanced Analytics, transforming process variability into predictable excellence, automatically, continuously, and at scale.